When you're building in the cloud, one tiny choice can make a huge difference. We're talking about the difference between a secure, cheap network and, well, an expensive, vulnerable one. And that choice often comes down to your VPC gateway. So today we're putting two heavyweights in the ring, the Internet Gateway versus the NAT Gateway. Let's figure out which one is the right champion for your setup.
Okay, let's start with the problem that every single one of us faces. You've got your app locked down tight in a private subnet, right, for security. But it can't just sit there in a bubble. It needs to get out to the internet for security patches, for updates, or to call external APIs. So the big question is, how do you open that door without letting every bad guy on the internet just walk right in? That's the exact problem these two gateways solve, but they do it in completely different ways.
And that's where our two contenders come in. I want you to think about it like you're designing a castle. Are you going to build a giant two-way public bridge for everyone to come and go? That's your internet gateway. Or do you post a really strict security guard at a small, hidden exit-only door? That, my friend, is your NAT gateway. Let's dig in and see which one you really need.
All right, first up, let's talk about that big public bridge, the Internet Gateway, or IGW as we'll call it. This is your go-to solution anytime you need direct, two-way traffic with the internet.
So what is an IGW, really? It's pretty simple. It's the thing that connects your VPC to the internet. Its whole reason for existing is to make your stuff publicly addressable. So if you've got a public web server that needs to take requests from anywhere in the world, you absolutely have to have an IGW. There's no getting around it.
So how does it actually work? Well, it's surprisingly straightforward. It just does a simple one-to-one translation. When your server sends something out, the IGW swaps its private IP address for a public one. When traffic comes back in, it just swaps it right back. It's like a direct phone line. The communication is totally transparent. It's two-way, and there's no one in the middle screening the calls.
Okay, from an architecture standpoint, there are two big things you got to remember about the IGW. First, it's super highly available. It's built to span your whole VPC, so it's not a single point of failure. Second, and this is really important, it is not a security device. Think of it as just an open doorway. The locks on that door, that's completely on you. You're the one who has to set up security groups and network ACLs to act as the firewall.
And now for our other contender, the NAT Gateway, or NGW. If the IGW was that big public bridge, the NGW is more like a security guard standing at a private exit-only door.
The whole purpose of the NGW is completely different. This thing is built for your back-end services, your databases, all the stuff you never want the public to be able to touch directly. It lets them reach out to the internet, to grab software updates or patches, but it acts like a shield, preventing the internet from ever starting a conversation with them.
Let's just walk through a packet's journey real quick. Okay, so first, your private instance sends a request. The NGW grabs it and basically hides the instance's real address, swapping it out for its own public IP. Then the request goes out to the internet. When the response comes back, it's addressed to the NGW. The NGW, being smart, remembers who sent the original request, translates the address back, and sends the packet safely home.
And here's the magic of it all. Because the NGW started the conversation, it knows to expect a reply. But any random traffic from the internet that tries to connect? Nope, it gets dropped right at the NGW's front door. Your private instances stay completely invisible. They are totally protected. Now, operationally, there are a few little quirks you need to know about. An NGW is highly available, but, and this is a big but, only within a single availability zone. So for real robust redundancy, you're going to need to deploy one in each AZ you're using. But the upside? Man, this thing is a beast. It scales automatically all the way up to 100 gigabytes per second. And just like the IGW, you can't attach a security group directly to it.
So, we know how they work. Now let's put them side by side and really compare them on the two things that architects lose sleep over: availability and security. When it comes to high availability, they're just fundamentally different. The Internet Gateway is basically set it and forget it. It's VPC-wide right out of the box. The NAT Gateway, on the other hand, is tied to a single availability zone. That means if you need your private stuff to survive an AZ outage, you are on the hook for deploying and managing a separate NGW in each and every zone.
And their security models? They couldn't be more different. An IGW is a totally passive doorway. It just lets traffic through and trusts that you are going to secure whatever is on the other side. But an NGW? It's an active gatekeeper. It inherently protects your private instances just by hiding them. It's security by design, not by configuration.
All right,
Now for the part that often makes the final decision for us, the cost. Let's follow the money and see how these two stack up on your monthly bill.
The cost story here is, well, it's pretty black and white. The Internet Gateway is free. Seriously, no hourly charge, no data fees. The NAT Gateway, however, gets you twice. You pay an hourly charge just for it to exist, and then you get charged again for every single gigabyte of data that passes through it. And that second charge, that's where the cost can really sneak up on you.
Yeah, it is worth saying that again for the IGW. $0. For a core, highly available, critical piece of networking, you pay absolutely nothing. It is one of the very few free lunches you'll find in the cloud.
And this is the number you have to watch with the NGW. That per gigabyte process charge applies to data going both in and out. If you have apps that move a ton of data, maybe for patching servers or sending logs, this can easily become one of the biggest line items on your entire bill. It's a silent budget killer if you're not careful.
But I've got a pro tip for you that can literally save you a fortune. If your private instances are talking to other AWS services, think S3 or DynamoDB, you should be using VPC endpoints. This creates a private internal route that completely bypasses the NAT gateway, which means you avoid all those data processing fees. For high-volume traffic, this is an absolute game changer for your costs.
So there you have it, the public bridge versus the secure proxy. One gives you free direct access, but you have to handle all the security. The other gives you built-in protection, but it's going to cost you for every gigabyte. The choice isn't really about which one is better, it's about using the right tool for the right job. So, now you know. What's the right mix of cost and security for your cloud fortress?